Hello and welcome to the third and final part to 7-7 as we look at applications of exponential functions. We looked at exponential growth in the compounding interest. Now we're going to look at exponential decay. And again, remember that decay means anything that's declining or decreasing, where that growth factor, that b in y equals a times b to the x, let me write that down here for you, that decay, if y equals a times b to the x, that means that b is 0 is less than b, which is less than 1. So b is in between 0 and 1. Here, that's the decay factor here. So something is decreasing. So here's an example of that. Atmospheric pressure is a great example of this happening in the world around us. This is kind of interesting. The kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level, okay, so that's where about where we live, give or take a few thousand feet probably, depending on how close you are to the mountains. But at sea level, if you're right at sea level, it's about 101 kilopascals. Okay, so that's sea level. So every time you increase 1,000 meters, a 1,000 meter increase in altitude means that the pressure decreases about 11.5%. Okay, I'm going to slide this over here, and if you jot this picture down, let's say that this is sea level right here, and that's 101 kilopascals. Okay, so this represents the ground at sea level. Okay, as I go up, if I increase, if I go up in the air 1,000 feet, okay, I'm sorry, 1,000 meters. That's the wrong label. 1,000 meters. That's a 1,000 in M right there. I know you can't see it. 1,000 M. 1,000 meters, the amount of kilopascals decreases 11.5%. So as you go higher and higher, it decreases faster and faster. Okay, so it says, what is the pressure at an altitude of 5,000 meters? All right, so you go up the first 1,000 feet, it goes down 11.5%, and then so that's a smaller number, and then that decreases another 11.5%. So you have an exponential decrease or an exponential decay here, because the new decrease depends on the new value as you go up above sea level per 1,000 feet. So let's again talk through the blanks here, see if we can really understand what's happening in this problem. It says if you go between sea level and 5,000 meters, the atmospheric pressure will decrease 5,000 divided by 1,000, because it's going down 1,000 meters each time, or in other words, it goes down 5 times. Okay, so it decreases 5 times compared to where we started with. So it says, write and simplify an equation to find the atmospheric pressure at 5,000 meters. All right, well, let's look at this equation right here. All right, look at this. This is exactly like we've been talking about in all the previous videos. Y is equal to, that's the A in this, y equals A times B to the X times, now this right here, this whole thing right here, that's the decay factor. Or in other words, that's B. All right, so A times, look at this right here, times, this is B, and then this is the X right here. That is the exponent right there. So it's really the same thing we're doing here. Now, you might be asking yourself, and you should, why is it 1 minus that decay factor? Well, the reason it's minus is because remember that the 1 represents 100%. The 100% is what it was before it changed. It was 100% of its value, but it's going down. It's going down 11.5%. And recall that as when we do the math, we have to convert the 11.5% into a decimal value, which would be 0.115. You have to divide it by 100. That should be a natural thing for you at this point in the class, how to change a percent to a decimal. So it's 1 minus 0.115 to the power of, now, to the power of, that's the number of times the pressure decreased. And how many times did it decrease? It decreased 5 times. Okay, because at 1,000, and I know you're probably thinking, well, it really decreases as you go. Yes, that's true, but you're really moving more into calculus if you think it like that, which is true, but we're not there yet. So we just have to think it does it 5 times, even though you're right, it's continually decreasing as you go. And again, that's just a higher level math thing that you'll be able to do in a couple of years. So let's just stick with this at this point. The decay factor, the last thing I want to say here, the decay factor is what this number right here is, and that's going to end up being between 0 and 1. It's 1 minus, and again, it's minus because it's decaying. It's decreasing. So what you need to do now is take this equation, 101 times parenthesis 1 minus 0.115 parenthesis to the power of 5. You need to practice with your calculator. And well, I'll break it down a little easier for you here. Let's make it y equals 101 times. Let's go ahead and do 1 minus 0.115, which is 0.885 to the power of 5. Now put that in your calculator and see if you can come up with, I believe the answer is 55. See if that works out for you. Now you might be looking at your calculator going, wait a minute, I got 54.8 something something. I went ahead and rounded this off. So yes, you're right. That's a little more exact, but I just kept it a little more simple for you because I read ahead and I saw that they went ahead and asked us to round it off to the nearest whole unit, which is 55. So it is 54.85 number, whatever that was there, but that is the rounded off to the whole number right there. And then the last part here I want to look at is just kind of wrap up what we've been talking about here. It says, I believe on the paper it says, do you understand the lesson check? How can you simplify the compound interest formula when the interest is compounded annually? Okay, annually is another word for basically one time per year. Okay, one time per year. Okay, well, so if it's compounded annually, it's once a year. Okay. Well, we would rather have it. We would like the most number of compounds in a year because we get the most money that way because we get interest on interest. If it just compounds once, that means they pay you one time for the money in the account. If they paid you daily, think about it. The first day you would make some interest, then the next day you would make interest, but that would be interest on the initial amount plus the previous day's interest. Anyway, that gets a little more complicated, which you'll learn that in a couple of years, hopefully more about that. When interest is compounded annually or yearly, the value of n, that means the number of times that it's compounded in a year, is 1 because it's compounded once. So it says simplify that compound formula. Well, the original formula was this. Okay, the original formula was A is equal to P times 1 plus r divided by n times n to the power of n times t. Well, if this is 1, that means that n is 1 and that n is 1. So we can actually simplify the formula like this. A is equal to the principal times 1 plus r over 1 would just be r to the power of n times t. 1 times t would just be t, which would be this right here, where that's really what they're looking for. Now that is only when it's compounded annually. And again, as an investor, or you with your money, hopefully you're wanting to make a lot of money. You don't want it compounded annually. You want it compounded as many times as possible in a year. But banks are smart enough that they're not going to do that every day, but they might do it a little more often, depending on who you know. And how that can work out. But that's the basic concepts of this. There's a lot in here. It's application of what we've been working on. Is it easy? No. It's going to take work for you? Yes, it is. So finish up these notes and bring your questions to class, and we will try to work them out at this point.